My name is Christopher Harnack, and I'm working with Analytical Mechanics Associates on the SPAR project. My role for the SPAR project is to model the power system components at more of a system level. So a lot of people are focusing on their individual components, kind of diving deep into the technical details of trying to improve their certain technologies. And then my role is to be modeling kind of the higher level system level effects of stuff like that. So let's say somebody wants to work on the radiator, make it lighter, more efficient, stuff like that. I'm kind of looking at it from more of a system level perspective. When you combine all the pieces together, is it helpful to be really focusing in on that, or is there some other effects that we want to look at? And then kind of seeing where we want each component to operate. So they're kind of trying, instead of working independently, at a system level to get a better idea of, at the end of the day, we want the system itself to be low mass, high performance, and so all the pieces work together. So my role is to look at how all the individual pieces affect each other, and then from kind of a higher level system perspective, reduce the mass, increase performance, make sure that things are compatible, the interfaces work well together. And then also start to look at trends of, okay, maybe we can tweak this component in this way, and that'll really help the system out from mass and performance perspectives. So kind of having a higher level overview of the project for the power conversion system kind of specifically. And a lot of that work's been focusing on really driving down either the reactor or radiation shielding mass right now, looking for ways to be creative with that or changing kind of the operating conditions of the design to reduce mass and improve performance. The research kind of area is maybe a bit unique because we're not focusing on a particular technology development in this case. So a lot of the research is getting a better understanding of how all the power conversion components operate. So for example, the power processing unit, kind of getting a better understanding of how that interacts with the system as a whole and other components within the system. So a lot of it's not so much kind of like academic research really, but kind of getting a better understanding of all the pieces in the power conversion system. A lot of the work being done right now is very early phase work, and so it's evolving rapidly and lots of cool things are changing quickly. So I'm getting a better idea of how all those components are evolving, what kind of the state-of-the-art status is of all those, so I can get a better understanding of how the system as a whole operates, and then try to help design the system to be most effective given all those kind of inputs and the current technology development status. So the next year, a lot of really good work was done kind of the first year here of SPAR, and kind of the first year, there's a lot of stuff getting ramped up. A lot of progress being made. So the kind of the first part of the next year is going to be focusing in on getting all that information back into the system model so we can kind of reevaluate a lot of the pieces. So kind of there's been a lot of good improvements made from the power conversion side of things. So we want to take those results and that progress and put it into our system model and then see what things have changed, what masses have changed, what performance has changed, and kind of reevaluate the system as a whole now that we're kind of about done with the first year. And then that's kind of the first quarter or so of the year. And then the big goal for next year is having that year 2 testing, doing a testing apparatus, testing out some of the technologies as an integrated system. And so then now that we have a system model, we can use that information to inform the system level testing. Maybe the conditions they want to use or what we anticipate the performance to be and how we can use the testing results to verify and validate our system model going forward. So my work is focusing in on really trying to make sure that all the pieces come together. So from the system level perspective, everybody's doing really great work, generally more in their own kind of technology development areas. And so my work is to combine all these pieces together, make sure that we have a really high performance, mass efficient system that really works well for providing lots of high power quickly to a spacecraft for lots of different capabilities.